Hi, my name is Mark Pariente. I'm a staff engineer with VMware. VLAN is a logical partitioning of a physical network at the link layer, that is the layer 2 of the network protocol stack. Hosts that are part of the same VLAN on the same physical network can communicate with each other. A VLAN is often associated to a broadcast domain because Ethernet provides the capability of broadcasting traffic to all the hosts in a VLAN. For performance, scale, or security, it is often necessary to isolate layer 2 broadcast domains. To separate the three VLANs in this diagram, the physical switching infrastructure has been replicated 3 times. For example, the management VLAN has a separate physical uplink on each host, and this uplink is connected to a dedicated switch. This solution would clearly not scale when the number of VLANs increase in the network. To carry several VLANs on the same physical link, the IEEE defined a special tag that is added to the Ethernet frame. The tag contains a VLAN ID, which identifies up to 4094 VLANs. Now, let's look at the network that we have previously showed, this time using VLAN tagging. A single physical link is necessary between the hosts and the switch. The VLANs are identified by their VLAN tags, not by dedicated cabling. A large number of VLANs can be created without any change in the physical infrastructure. In the data center, hosts are connected to different broadcast domains to preserve isolation, but participate in common VLANs. A virtual machine that migrates across different broadcast domains does not lose its VLAN configuration either. However, virtual machines residing in different VLANs, even on the same host, can communicate with each other only if they are connected to a router device. Vsphere supports different modes of tagging packets with VLAN information: external switch tagging, virtual guest tagging, and virtual switch tagging. You can choose the mode that suits both the needs of your organization and your network setup. Configure tagging at the port group level to ensure that VLAN traffic from related virtual machines or the VM kernel is managed in the same way. In external switch tagging, when a packet from the host arrives to the physical switch, the switch assigns a VLAN ID to the packets. The physical switch strips the VLAN ID when it sends packets back to the host. The ESXi host is not aware of the VLAN configuration on the physical network. A NIC on the host is connected to the physical switch through an access port that can service an individual VLAN only. The maximum number of VLANs on a host is equal to the number of its physical NICs. You can turn on external switch tagging for the virtual machines or VM kernel adapters in the Vsphere web client. In the VLAN policy of the port group, set the VLAN type to none. In external switch tagging, the number of the VLANs on a host is limited to the number of its physical NICs. To avoid this restriction in an environment that needs many VLANs, use the modes that we are going to discuss next. In virtual guest tagging, the VLAN information travels from the network through the virtual switch up to the guest operating system. The guest operating system must have a network driver that understands VLAN tags. The NICs on the host must be connected to trunk ports on the physical switch. A trunk port, in contrast to an access port, can handle traffic that belongs to many VLANs. In this way, a NIC can send traffic for more than one VLAN. A number of VLANs per virtual machine is not limited to the number of physical NICs. In the Vsphere web client, to turn on virtual guest tagging for virtual machines on a standard switch, set the VLAN ID of the port group to all. As a result, the guest operating system can exchange packets from all VLANs. Letting a virtual machine access any VLAN carries a security risk. You can configure a distributed switch to pass only packets that belong to specific VLANs. In the Vsphere web client, set the VLAN type to VLAN trunking, and set a VLAN range and individual VLAN IDs. With virtual guest tagging, you configure VLANs individually on each guest operating system. On a host that runs many machines, you might spend a lot of time until you deploy the right VLAN topology. A guest operating system also demands CPU cycles to tag and untag packets. Now, let's look at the last mode, virtual switch tagging. In virtual switch tagging, the virtual switch is responsible for tagging. You reserve a switch port group for a VLAN and connect the adapter of the virtual machine that must reside in the VLAN to the group. When a packet arrives from the network, the switch removes the VLAN ID and forwards it to the target virtual machine. When a virtual machine sends a packet, the switch adds the VLAN ID before it transmits the packet to the network. the VLAN information goes from virtual switch to the physical switch. Like in virtual guest tagging, packets from many VLANs are consolidated on a single physical NIC that must be connected to a trunk port on the physical switch. To turn on virtual switch tagging for the virtual machines in the Vsphere web client, set the VLAN type on the distributed port group to VLAN and enter a VLAN ID between 1 and 4094. With virtual switch tagging, if a virtual machine has to participate in a lot of VLANs, you must create as many adapters on the virtual machine and port groups on the virtual switch as the number of VLANs. Then, for each VLAN, you must pair the adapter and the port group. For a complex VLAN topology, you can combine virtual switch tagging and virtual guest tagging on a virtual switch. Using VLANs in Vsphere helps you adapt the environment to network changes. VLAN modes overcome the limitations of the networking equipment and of host physical connectivity. To learn more about VLAN configuration and other Vsphere features, visit pubs.vmware.com.